Sorry about that, crew. Again, that app that I use for that, I'm only limited to 15 minutes, so this is part 2 of your dilation videos. If you're wondering, yes, I did go change because it takes a while to upload those videos. It gave me enough time to go change in the middle between these videos. But in any event, we left off in the notes right here where we were graphing some dilations. So it gives us pre-image points up here and then a scale factor, and we have to come up with the image points. So down here, again, my scale factor is 0.5. These are my points. So to come up with these image points, I just need to multiply that scale factor times each one. So to do that, again, I'm going to do 0.5 times 2. Well, half of 2 is just going to be 1. So E prime works out to be negative 1, comma 1, negative 1. So like that. That would be my E prime. My F prime, again, half of 2 is negative 1. Half of 4 is 2. So that ends up being negative 1 comma 2. Then if I take a half times 2 comma 4, so that's going to end up being 1 comma 2. So that's G prime. 1 comma 2. And then down here, H prime, again, I'm going to multiply each of those by 0.5, so just take half of both of those. That'd be 1 negative 1. And since that scale factor is less than 1, it should be a reduction, so it should be smaller. So let's see, I'll graph the image first. So before the dilation happens, I'll draw that one in blue. So let's see, negative 2, negative 2 would be down here. Then negative 2, 4. 1, 2, 3, 4 would be up here. 2, 4 would be up here. And then 2, negative 2. It ends up being there. So this is now my pre-image in blue. Well, it's going to be black lines. So that's my pre-image. So then I graph my image points here. I'll do those points in red. So negative 1, 1, or negative 1, negative 1, that's right there. Negative 1, positive 2, 1, 2, 1, negative 1 is right there. So now you can see the smaller reduction that happened because my scale factor was 0.5, which is less than 1. So that's why I ended up with a reduction. So over here, similar problem, except it's a triangle. Again, I have my pre-image points here with a scale factor of 2, so now that's an enlargement, so I'm going to multiply this times the image points. So I end up with 2 times negative 2 is negative 4, so it'd be negative 4, negative 4. Then it would be what, negative 2, 4. And then I would do 4 comma 2. Alright, so let's graph everything. So pre-image I'll do in blue again. Negative 2, negative 2. That's right there. Negative 1, 2. That's right there. And then 2, 1. That is right here. So I'll connect those with a straight line and show you my pre-image. So then I'll graph my image points in red. So again, it's an enlargement. I know that because my scale factor is 2, which is bigger than 1. So it would be a negative 1, 2, 3, 4, 1, 2, 3, 4. First pre-image point, negative 2, 1, 2, 3, 4 is up here. And then lastly, I got 4 comma 2. 1, 2, 3, 4, 2. So I'll connect those with a line, and you can see my enlargement then because my scale factor is bigger than 1. That would look something like this. That's how you do a problem like that. All right, next, scale drawings, remember, are similar figures, and they're just enlargements and reductions depending on which way you're looking at it. But down here it says these are real life situations involving these dilations. It says the packaging list models a car's length at 7.6 centimeters. So that is a model car. It gives me a scale factor of 1 to 63. What's the length of the actual car? So again, this is the reduction. It goes down to this. So I'm going to use 1 to 63. So since that is a ratio, that means 1 unit on the model is equal to 63 units on the actual. So I'd set up a proportion here, and since this 7.6 is from the model, it goes up where the 1 goes because that's from the model there. So that would be 7.6 over what I'm looking for, the corresponding length of the actual one. So just kind of cross multiply those, and basically I do 7.6 times 63. So 7.6 times 63, and that'll give me the corresponding actual length. And that is 478.8, and that's in centimeters. Total 478.8 centimeters. Centimeters. Yeah, we don't type that out. 478.8 centimeters. I did just get a tablet and an iPen. I'm hopefully going to get that up and rock and rolling soon, so you'll be able to read my writing. In any event, here's another problem here. The height of a tractor trailer is 4.2 meters. The scale is now 1 to 54. Find the height of the model. So now I got to go in the other direction. I have the actual length, and I need to find the model length. So I use my scale factor of 1 to 54. And I'm going to use that in a proportion. And the part that I know is the actual measurement is this 4.2, and so it goes down with the 54. I'm looking for the height of the model. So again, I just cross multiply here. So I'm going to end up with 54x.
I'm not going to do this whole thing where you just act like this all the time. I'll just work on my work, and if you want to go on a device 100% of the time, that's fine.
All right, so next I got to divide by 54. So 4.2 divided by 54. So then you get this 0.077. So you got to remember that that's in meters. So let me write that down. 0.0777. So where are we at? 0.077. But you got to remember that that's in meters. And so I got to transfer this to milliliters. Remember, milliliters, there's 1,000 milliliters in a meter. So that means I'm going to move this decimal place 3 times, because that's how many zeros are in 1,000. So I'm going to move it 1, 2, 3 times. So that'll end up being 77.8 if I round it to the nearest tenth. 77.8 millimeters. So again, that's how you do a problem like that. Down here, that's another dilation that's centered at the origin. It's always going to be at the origin. It's never not going to be at the origin, so you don't have to worry about what that means. Always going to be that way. So now I'm going to use a scale factor of 4. It's an enlargement. I know that because the scale factor is bigger than 1. So let's see. Point P, where the pre-image point, is at 2, 1. Wants me to give graph point A with a scale factor of 3. So, well, if I'm going to do that, and I use a scale factor of 3, that's going to be what? 6, 3? Then, so that'll give me A point A. So I'll draw that out here. So 6, 3, 1, 2, 3, boom. So then, this is the pre-image point here, 2, 1. Then it wants a scale factor of 5. So 5 times 2 is 10. And then 1 times 5 is 5. So that means point B will be at 10, 5. I'll graph that in blue. So that'll show up right here. And then a scale factor of 1/2, that's going to put me at 1, 0.5. So I'll draw that in a different color. I'll use green on that one. So 1, 0.5 is right there. Again, they're all centered at the origin. That's never going to change. So you'll notice now this ripple effect that I mentioned before. Remember throwing the rock into the pond? You can kind of see here what happens. The center is going to always be at 0, 0. And then all of these points had the origin as the center, and it kind of ripples away from the center, and they all end up on that same line. So that is that ripple effect that I was talking about. Down here it says label A, B, C, and their coordinates. What are the coordinates for dilation with scale factor of 4? So that's another enlargement there. I'm just looking to see if there's any different types of problems. This one's a reduction, so it has an enlargement and a reduction. So down here's a closure question. It asks, in a dilation, the pre-image and image are similar. Remember, they're similar with a scale factor, but they are totally not congruent. Therefore, a dilation is not an isometry. Remember that a reduction is going to have a scale factor that is less than 1, and that enlargement is going to have a scale factor that's greater than 1. So the rest of the notes, if you want to see this enlargement and reduction, that's in the notes there, of course. Then I did include homework in there where you're going to be doing enlargements and reductions, graphing them, and identifying them. They are also in this folder. Look forward to looking over those. Again, as usual, if you have any questions, please let me know. And I will see you guys soon. Thank you very much.